So in this problem, you're asked to find the empirical formula of a hydrocarbon. The first thing you've got to notice from the diagram that's given is that there are 4 carbon dioxide molecules, represented by the black and red spheres, and there are 5 water molecules, represented by the red and white bent molecule, sort of Mickey Mouse shaped structure there. You also need to know a little bit about combustion, specifically the combustion of a hydrocarbon. Combustion always involves the hydrocarbon plus oxygen gas, and it always produces carbon dioxide and water. You then need to know what a hydrocarbon is. Well, it's, as the name suggests, a compound that contains both carbon and hydrogen. So a more detailed look at the combustion equation is given now. Again, the hydrocarbon plus oxygen produces CO2 and H2O. If you look closely at that equation, the only place there's carbon on the right-hand side is in carbon dioxide. So the number of carbon atoms or moles of carbon that are present on the right side all came from the hydrocarbon. The same with water. Water is the only source of hydrogen on the right side of the equation, and the hydrocarbon is the only source of hydrogen on the left side of the equation. So those numbers are going to have to agree. So now if we have 4 CO2 molecules and 5 H2O molecules, and we know that all of that carbon came from the hydrocarbon and all of that hydrogen came from the hydrocarbon, we simply count up the carbon and count up the hydrogens, and we come up with a formula, C4H10. Well, now we've got to go one more step. And that next step is, well, what does empirical formula mean? If we don't know that, we have no hope of answering this question. Well, empirical formula simply means the simplest whole number ratio of atoms or simplest whole number ratio of moles of the elements in the compound. C4H10 is not a simple whole number ratio. You can simplify that down. You can factor 2 out of each of those numbers, and you get C2H5.